Today, we have got something truly intriguing lined up for you from the science that surrounds us, and it all begins with a molecule we often take for granted, H2O. You might think you know water, but there's a side to it that's as surprising as it is mesmerizing. Water, the everyday substance that makes 71% of the Earth's surface. It flows from our taps, fills our oceans, and quenches our thirst. It is truly remarkable for a multitude of reasons. One of the most intriguing aspects is the way it effortlessly transitions through all three states of matter: solid, liquid, and gas. What's even more fascinating is that it behaves uniquely in each of these states. In its liquid state, water is the lifeblood of our planet. It flows, it hydrates, and it sustains all living creatures. It is essential for our survival, but it's also a powerful force of nature. Water's ability to dissolve a wide range of substances makes it a universal solvent, capable of shaping landscapes and carving out canyons over millennia. When water transforms into vapor, it becomes an invisible force, often escaping our notice. Yet, it's ever present in the air around us. Water vapor is responsible for weather patterns, clouds, and the beauty of a glistening morning dew. It can be gentle, forming delicate mists, or mighty, gathering into towering storm clouds ready to unleash their power. But what if I told you that this common substance has an extraordinary secret? A secret that unfolds when it undergoes a remarkable transformation. Ever wondered why water behaves so strangely when it freezes? Stick around because by the end of this video, you will have all the answers. When water freezes, it does something truly unique: it expands. That's why ice floats, and it's also why those cans and jars can sometimes bulge or even explode in the freezer. But here's where it gets even more intriguing: when you compress water, it melts. Imagine the pressure it takes to melt ice, around 500 times atmospheric pressure. Imagine, for a moment, a world where ice sinks instead of floating. A world where the simple act of freezing water could trigger a chain reaction that defies logic. Well, guess what? Such a world exists, but not in the way you might think. Today, we're delving deep into the fascinating phenomenon of water's expansion and its incredible consequences. Buckle up, because we're about to uncover the secrets of the expansion of water. You might be wondering why we are making such a big hype around the expansion of water, right? It's just a liquid, right? Wrong. You see, the expansion of water is a topic that's both mind-boggling and essential for our understanding of the natural world. Now, picture this scenario: what happens when you try to freeze water while it's under immense pressure, inside a super strong vessel? It's a puzzle that seems to lead to a paradox. As water freezes, it expands, but if it's frozen, it creates pressure, which should make it melt. It's a loop that keeps going, or is it? Under normal atmospheric pressure, as you cool water down, it transitions from a liquid to a solid, which is what we would expect. However, when you increase the pressure, something incredible happens: the solid water turns back into a liquid. This is where things get really intriguing. As you keep cooling the container, more and more water molecules try to freeze, but as they do, they expand and pressurize the container. This pressure prevents more liquid water from freezing. As you lower the temperature even further, you reach a point where the remaining liquid water can freeze into a different phase of ice, known as Ice 3. Unlike regular ice, called Ice 1H, Ice 3 contracts and becomes denser as it freezes, creating more space. Ultimately, the entire container can freeze solid, though it'll have a mix of Ice IH and Ice 3. Water's phases, it turns out, are far from binary. Now, let's talk about ice, not just any ice, but two special types, Ice 3 and Ice 1H. These aren't your regular ice cubes, that's for sure. Ice IH, regular ice. First up, we have Ice IH, which is basically what we think of as regular ice. It's what you see in your freezer, what forms on a chilly winter day, and what you use to cool down your drinks. It freezes, it expands, just like we've been talking about. Now, let's shift our focus to Ice 3, the mysterious variant of regular ice. When water is put under extreme pressure and super cold conditions, it doesn't quite freeze into the ice you're familiar with. Instead, it transforms into ice 3. This ice is a bit of a rebel. Unlike ice IH, when ice 3 forms, it actually contracts and becomes denser. It's like water's way of saying, I'll freeze, but I'll do it my own way. And that's the beauty of science, it continually surprises us, offering new perspectives on the world around us. As we close this chapter on water's secrets, remember that there's always more to discover, always more to learn. Well, that's it for today's video. As we wrap up this mind-expanding adventure, remember, the universe is full of wonders waiting to be explored. So, keep that curiosity alive, and stay tuned for more jaw-dropping revelations on Physics Daily. If you enjoyed today's dive into the physics of our everyday lives, be sure to hit that subscribe button, and don't forget to ring the notification bell. Until next time, keep exploring the wonders of our universe.